Okay, then I think we can start. Hi everyone. Thank you for coming for this session. I'm very happy to be here back in real for Android makers. I'm Arnaud Giuliani. I'm a Kotlin GD and also I'm the Koin project lead developer, and started to create Koin in 2017, and here we are still on stage to present new stuff about Koin. Today I would like to share with you recipe about how we make architectures, how we can write applications from the classical architecture style like MVP, MVVM to the, let's say, more shinier architecture like Compose and multi-platform. Just before to start, I would like to know you a bit better, and just raise your hand if you already use Koin in the room. Yeah, most of you then. It's a good thing to see. But I always keep some core concept for Koin, because just to recap things for those who don't know Koin and just want this slide. If you don't know Koin, just try it. It's super easy and nothing to add. But just to remind you what the basic concept of Koin is, as a dependency injection framework, the idea of Koin is to provide a full Kotlin solution to give you the possibility to describe your components. If I have those two classes here, I can describe them directly in a DSL, a Kotlin DSL. This is something that is compiling in your code, and then you are describing the components that you want to inject in your application. And then here, as you may know, we fill all the constructor to say to Koin to say, okay, retrieve me the dependency I need it here. And in a few keywords, this was the magic of Koin, is that in a few keywords, you can describe mostly everything for your application. And even for people that don't know the technology, you just read, and mainly you understand, and you can quickly work with that. As a reminder here, when you describe things in a module, Koin will build everything for you, and you will mostly use constructor injection. That means that your classes are not depending at all on Koin API. On the other side, the other power of Koin was to provide a very shiny mechanism to help you retrieve from anywhere your instance in your application, from in Android, in Ktor, any kind of runtime that is using Kotlin. And then to unlock the by inject function, then we have what we call the Koin component interface. That is finally an interface that helps us bring you the extensions for you, and then you can have magically the by inject for your class. When you are using Android, we are providing directly all those extensions for you. Now that we have seen those basics of Koin, let's dive into the real stuff that I want to show you today, and we begin by the classical MVP, MVVM architecture. To show you this, I like to take sample application, and one, perhaps the well-known in the Android community, is the Android architecture blueprints. This is a project that is contributed by Google people, GDE, and other contributors that help to provide all the architecture patterns, how you can build your applications in Android in a different kind of style. You may see the original URL, the first one, and the second one is a fork in the Koin repository, if you want to find back the source that I will show here. Then, this application is just a simple one, a super fancy application with one button. And the idea is to add to-do inside, and then you have a list of to-do things that you can then delete one by one. And I don't want to dive into much complex things today, but just we can take a simple application with one activity, and behind we will have a classical organization of components with a view model, with a repository, where finally this repository will help us drive our kind of data sources from local storage to remote storage of our to-dos. And then, because we are crazy, we have local database for that. And then how we can write it super easily with Koin. Just to begin, since Koin 3.x, you just need one module to work with all the Koin features for Android. And you don't need to mention any more view model, scope, and fragment modules. Then, if you still have that in your Gradle configuration, you can remove that. And then we are going to declare each component one by one, and you will see how we can configure some typical configuration in this kind of application. Then we have a first data sources, type task data sources. Then we can declare it with just single of the target type with the constructor of task remote data source. Nothing fancy here. If we have two data sources of the same type, two different implementation, what we'll have to do, we can declare the two components. The second one is resolving two dependency. But then, if you don't do anything else, Koin won't understand what kind of type you want to resolve when you are asking for task data source type. Then you need to add a qualifier. It's just a label that helps you target the right instance for you. Once we have our two data sources, we want a repository to wrap up this data sources logic, and then we want to drive this and call the right stuff. Then we declare our component with 3 gets here, and then for the right instance, you need to put the name, you need to put the label of the components that you want to add here. Once this is done, the other stuff is that on the local data source, we want to declare some API, and we want to use room, for example. And the magic of Koin is that behind your Lambda, when you are calling a single definition or factory or something, you can write anything that is in Kotlin. Anything. That means that I can just pass this line of declaration for room, and then I can declare directly the data source, the database for room here, and then it will be referenced in Koin. You can also notice that we can use the expression Android context. This is a function that helps you retrieve your Android context anywhere in your Koin declaration. Also, the good thing is that dynamically, to define another thing, you can dynamically retrieve one component, like our database instance, to do something with it. And then from here, for example, we are taking the database, the room database, and we want to extract the DIO directly. Then we can extract this DIO definition directly with one line like that. Very easy to write. And then we go with the classic task view model here that is using a repository and a safe state handle for those who are working with state. Just use the view model declaration, get and get. For the safe state handle parameter type, you don't have anything special to do here. And then you're gone with that. And then you're mostly done, because now you have declared a bunch of components, and then in your activity, bam, you just use by view model. And then you have all your view model, it will resolve everything for you. If you are more in MVP architecture, that means that finally we switch our view model for a presenter component. This is not really making the difference here. The only difference will be our task presenter, where finally in our MVP we want to pass a contract back to the view to have some callback to the UI, and then this is what task view is doing here. And the magic of Koin also is that it's a function, as I was saying. It's a function of Kotlin, and then you can pass things directly to your construction and says, okay, when I want to construct task presenter, I want to pass you a parameter to help you construct these things at this time. This is what we call injected parameters, and then you can declare it with parentheses with the parameter you want to pass, and then arrow, and then your object to construct. And then this is really visual. This is really interesting to resolve, and then you can pass things from the UI, how it's going. We are using by inject here, because it's not a view model. The by view model is the same as by inject, but we are registering all the instance in the view model factory for you. And then it's the Android system that is dealing with your instance for you. Then in by inject or by view model, you can open a lambda expression to help suggest to Koin, then I need another parameter to help you to construct my instance. And then you open the lambda and say parameters off, and then you pass a list of things you want to pass, and then you get it in your definition. And then you're done. It's really the dynamic side of Koin, and then you can pass things to, for example, NID, for example, components for dynamic linking. Then it's really interesting way to build things. It's an overview of everything we have written down, and then you can easily reread all the definitions. If the previous all definition is one module, you can organize yourself in the way you want. That means that it's not the tool to say to you how you want to organize, is the tools to adapt to you and to help you to organize your modules. And then there is no constraint to organize yourself. The only constraint, finally, it will be when you want to launch this module or this list of modules to have the right definition, because else you can miss something. But you can compose several modules. You can use the add operator here, the plus operator, between modules, and then it will bring all the modules inside one list. And then you can, we have the app module value here, and then we define our start Koin here. We use directly the app module. Then you can split things, whether you want to test, whether you want to organize in feature, whether you want to organize yourself about how you want to deal with your code. It's not a problem with Koin, because finally we run things for you, and then we can find at the runtime everything for you. If we are a bit crazier and we want to deal with clean architecture, it's not a problem, because finally we will just add another layer in our application that will be more about abstracting the logic, the business of what we are doing here, is that we want to retrieve something, the task here, and it's just another layer between the repository and the view model, just to extract the logic of this, and then to not have everything in our view model. Okay. How does it change for us? Finally, the view model is referencing not the repository, but directly the get task use case here. Okay, not a problem. We still have get, no problem. Koin will deal with that. And after that, we have another component, get test use case, that is referencing to the task repository, not a view model here. And then we declare it as a factory directly. We don't need anything else. Then, in terms of components, finally, if you add something that is on the same life cycle, I will come back later on that, you just need, if you have interactor, use case, things that follow up behind your view model or your presenter, you just need factory things, because you don't want to hold an instance for them. You just want to create an instance behind your view model and to drop it after later. And everything else, you see, you can just declare it as a singletons with single keywords. Let's wrap up. What we have seen here is that we can declare your logical layers in factory or view model. Here, for task repository data source and all the databases, this is just single. And then you don't need much more than that. And on the UI, then you just need the Koin API. If we add the interactor or the use case here, it's just a factory. and then you're done. You have mostly everything written down, the kind of definition that you need here to write your application. In a more, let's say, abstracted way, you have the Android UI, the presentation layers, interactor, and then repository and data sources, and that's it. I believe it can help you see later. This is really the basic way to build the applications with Koin and to have the basic structure. On the logical layer, we can have more fancy stuff, and when we begin to work with scopes, it's usually like that. And because why? Scope is finally the idea that we want to keep the same instance for a specific amount of time. We want to keep the same amount of objects for just a right defined time, not a singleton, not a factory, because we want to reuse the same stuff. And one particular scope that you may know is the Android one, because then we need to work with Android lifecycle, and then we want some time to deal with some tricky component lifecycle on the Android side. Then how we can do that? With Koin, you can just follow the Android components. That means what? That means that if you want a presenter to follow your UI, you just need to describe it as a factory. And that's it. We will create an instance, the UI will receive it, and then it will work with your instance. And then when the UI drops, your presenter will drop also, and then when the UI is recreated, then we recreate a new presenter. And then you don't need much more than that in terms of MVP, for example. If really we want to work with a scope, that means that for this example, we have a presenter that is dealing with the adapter, and we want also to have the same instance in my adapter classes, in my activity. That means that really we want to deal with this class, and we want to have the same instance. Here you see that we are using scope activity class. That is something bring by Koin to help you override the standard app compat activity, but you can do something in your own class over the app compat activity by hand. I show you just after that. But the idea of declaring a scope, you just see in the bottom boxes that finally we just declare a scope space of the given type, scope of my activity, and then you have scoped definition, the thing that we want to maintain in this scope while we are maintaining this time. Then we will maintain the object for you. And what does it mean? That means that finally, when the UI is creating, we create all the objects and we maintain references, and when the UI is dropping, we drop also the activity. The things here, we are not in view model, and then we'll still follow closely the activity component lifecycle, and then your scope will drop with that. But you maintain a consistent set of objects for all of that. The view model, then really, I believe the good thing here, and I forget the view model extent here, you just need to declare view model definition and then use the by view model. And in your activity here, you see that your activity will drop, configuration changes, your activity is destroyed, but not your view model instance. And then when your activity is recreated, then we keep the same same view model instance. You can do the same. If you want really to maintain things over activity drop, or if you want to maintain, here for example, if you want to maintain my adapter across the activity lifecycle, what we can do is override the scope here. You can override, say, override scope by activity retain scope. By default, we will have the activity scope, and here you say, okay, I want an activity retain scope, and then we will provide a view model for you that is backupping everything, and then we will survive to configuration for you. This is the same as Google is doing, and then we can back up everything, and then everything is surviving to your configuration change. But really, I believe if you need to think about scope, really think if you really need it before diving into complexity. The other view model kind that you may want to use is the navigation graph that is really stored in a dedicated way, and then we have a dedicated project for that, Koin Navigation. And what we have here is you have your navigation view model. That means it will be a view model that is tied to your navigation graph. And then you can observe things along all the navigation, along all your views, and then you can play with your view model. The only thing for you here to note is that you just need to use Koin Nav Graph view model that will help to register everything, and then you pass the ID of the nav graph, and then you will hold, it will hold your view model at the navigation graph storage. If you don't do that, you may recreate view model and then dive into problems with that. And here's the solution for you if you want to tie your view model with your navigation graph. Let's wrap up. To define a scope, in your modules, in your module section, then open scope, the scope, a scope section like that, scope of the given type. You can even give a qualifier if you want to make something really custom with just an ID, something that is not tied to a type. Then you can use scope with a qualifier. But the best, for example, to describe a scope for an activity is scope of the given type. And then you can use, in this section, you can use scoped keyword to scope anything that is need to be kept in this section. You can also use factory, you can also use view model to resolve things in this space. Because then if you put view model outside of the scope, you can't resolve my adapter, for example. To use the scope, you either have the way to use directly scope activity, and then you have everything written down for you, and then you have the activity scope by default that is done here. The other way to do that is override Android scope component interface that gives you a default scope. And then you just need to describe a scope, and when you use by inject by view model, we will look at the defined scope, and then we will resolve in the given scope, and then after that we fall back in the other space definition that you have in Koin. If you want to play and you live dangerously, you want to play with scope API directly, you can use the scope API directly with get Koin from any UI or any components. You can create scope, you can get scope and then retrieve it if you give an ID, and then you can retrieve your instance from that. This is from there. If you want to have a custom scope like wallet, like this kind of things you want to maintain over the time, perhaps this is where you can look at, because you want things to be maintained over several activities, for example. And then don't forget the Koin navigation graph view model to hold your view model for the navigation graph. The only added stuff here is you see that on the logical layer, on the presentation layer, we can then have as factory view model or use a scope if you want to maintain your presentation layer in any other way of the factory of the view model. And that's it. Finally, you can see that it's the big picture that you have to keep in mind is this. If you are using the classical architecture, this is mainly the way that you are writing your application. My main advice is keep your config simple, because as Chet has is saying, less code equals less bugs, clearly. It's time to see new architecture, because people don't want to do really anymore MVP, MVVM. Even MVVM can be fancy, but we can talk about more fun stuff like Jetpack Compose, because finally, you can already use Koin for Jetpack Compose. You just use Android X Compose, Koin Android X Compose module, and then you're done. And then in any composable function, you can access your components with get or by inject if you want a lazy instance. And also, one advice is that if you want to inject things in your composable, is that you can use the default parameters here, equal something, to use Koin, and then your composable will, by default, use Koin to inject the values you want, but then you are not blocked by Koin. That means that if you want to test and inject things manually, you can then, and then you will override the default parameters value in your function. And then you can use freely Koin. I would say one of the main forms is to have parameter functions. Of course, we have the view model, the by view model, and the get view model way, and the same approach. The good thing is to have it either in parameters, in a parameters function, to help you override the things and to be not linked directly to the Koin API, either to use it in your block directly. We begin to work on this. We forked the default Jetpack Compose samples to demo how we can play with Compose and Koin and inject things around. Then you can see the repository here. Things are not are just starting for Compose, because then we just start at looking what is really the usage. What really we need in terms of DI for Compose, because perhaps it can differ a bit in terms of injecting the UI, but then it will be only the differences, because finally all the other components that you are defining, repository, data sources, other components, finally you will need them. The only things that change is finally just at the UI side. And is the picture that is wrapping up everything I just told here. Is it doesn't change your big picture architecture, it just changes the way we are using the Koin API in Composable, and then you can scroll everything in your, let's say, classic configuration for Koin, and then you can go up. The good thing for Koin is that it's one of the dependency injection for Kotlin multi-platform. Also named by JetBrains as the last keynote. But yes, Koin offers Kotlin multi-platform for the mobile side and not also the mobile side. What does it mean? It does finally on our super shiny Android application, you can begin to think about using all the native UI and then having the presentation layer, all the other components. And what can offer finally the multi-platform is that you will reuse all the main, all your common Kotlin code directly for Android and iOS. What does it mean is that finally you can use directly your Koin configuration as a shared common code as a shared common Kotlin code. The only boundary is about presentation, where your view model in iOS won't be exactly the same as our view model in Android, mainly because of all these coroutine stuff that are not super multi-platform for now, but we are getting our multi-platform architecture really cross-platform and just getting sticking to the native stuff. One application I like to play with is one from another Kotlin GD, John already, from Ireland, and then he liked to play and build up a demo application in Kotlin multi-platform. Then I like it also because there is Koin inside, and the People in Space application is a mobile application that is using ISS data information about the location of the ISS station on the map, and then who is inside. Then you see here is the perfect establishing, it's the perfect mobile application, Android and iOS, and is using Swift UI, and also on the Android side there's Compose. But then behind that, if you check out the project, you begin to compile everything, then you see that there is all the kind of application from the Android one, the iOS one, the web, desktop, and backend. And on the command side, it gathers everything, and then you can just write a module with your pure Kotlin code. Why? Because finally Koin is pure Kotlin, and then you can describe everything that will be cross-platform for you. That means that you declare a common module with finally your JSON serialization in a multi-platform, your Ktor client, your data repository with your remote access, logging. You may have, you may need some library like SQLDelite for the database storage that may need some native configuration, and you can still play with Koin to describe how on each platform you may need a different module to configure your SQLDI driver. How this is done on the common side of the application, we have something expect fun platform module. That means it will be something that we want to redefine in each platform, and then we want a dedicated platform module to describe everything we want in this native configuration. And behind that, we may have a JVM SQLite driver configuration. And for example, on the iOS side, we want to instantiate the native SQLite driver component. And that's it. You have everything on the common side. You can gather every component. But for the special binding for the native side, you can still use Koin to inject the right configuration for that. And then, finally, on the Android side, you see the module is just one line. It's a view model for the people space view model, and then we retrieve the repository that is declared in the common modules. In the iOS side, it will be the same. We will reuse directly the people repository, the people in space repository, directly in an instance of Swift view model. The big picture from the beginning, you can still apply the red line where you can share code, and then you can share configuration with Koin on it. And then it's really interesting to open yourself if you really want to dive into Kotlin native, Kotlin multi-platform. You can still work with Koin to help you declare things and declare and share common components. Yeah, now time to share with you some new features and a new feature proposal I'm working on since a few months. As we begin to see, the power of Koin is the DSL, because it helps you really quick start super easily in a few minutes, and then you are injecting everything you want. But then also there's limits, because then we can't really analyze everything in your DSL. Can be very difficult because then everything is runtime. And then one of the solutions is to look at the power of Kotlin compiler plugin, and then to begin to say, okay, what can we do at this side, at the pre-compilation side of the project? What we propose here is that finally we can propose another way to work with Koin, a way to complete the way we are working with Koin, the DSL, but then with Google Key SP, we can make annotation processing in a super fast way. The idea is that we want to keep the semantic of Koin. We want to keep a super easy, fast way to work with annotation. And then your goal, and then you can use the Koin API directly. Let's see how it works. It's already online. You can play with it. It's Koin annotation 1.0.0 beta 2, and then look at the InsertCoin.io website to have the dedicated setup information for KSP, because you need to configure KSP to help you generate the stuff. We come back to our super shiny to-do application and how we can do that with just annotations with Koin. We have our first class, we say, okay, add single, and that's it. The component is declared, and then you can already retrieve it. We have two components here of the data sources, we just say add single, okay. We want to add a named, which says add named, then nothing here. The task repository, you just say add single because we want a singleton, and then on each parameter, just say at named with the right label, and then you're done. On the view model, you just say add Koin view model, and then you declare everything. You just have the same schema as the basic DSL for Koin. And then on the activity by view model, bam. And mainly, if you have also the presenter, you just can tag it at factory. We keep really the same semantic as the DSL. And because we have an injected parameter, we want to say to Koin, when you analyze the stuff, when you want to write the code for us, this will be an injected parameter here. And that's it. You know that you will be able to use parameters of behind your inject lambda expression. Factory, at Koin view model, at single, and then the Koin API. This is not changing much. It's just another way to help you use Koin, because for some people you may want to use annotation to scale more in terms of writing. You may want to mix also things between DSL and annotations. For module, then, if you want to gather things in module, what you want to do is just have a class, tag it module, and then you can scan everything in terms of package and say, okay, I gather all those definitions from this package into this module. And that's it. Just tag what's your stuff. You don't even need to declare a module. If you want, we can generate a default module for you. But then it's super, super fast. You don't have to care about your definitions. And then, to start your module, the only generated stuff for you is this extension.module. The only thing you have to do is instantiate your class module, and then we give you the .module extension for you. That means that from the class and everything we have scanned around, we generate a Koin DSL for you. And this is just it. We just generate the DSL you would have to write by yourself, but it's another way to help you to write things more and more fastly. And you can even mix classic DSL module and annotated module. You can meet things, because then you can begin to write or play with the annotation on one small module, and then you can add it in your application. You are not blocked by a way or another to write with. And you can even, in a module, declare a function directly. On a function, you can tag it with factory, single, or something else, and then we will make this function a definition, and we will write the DSL for you. Then it's interesting because the DSL is super powerful for so many cases, but also annotation open other ways to express yourself for Koin. But the idea is to keep it super simple and super readable for you. Then it's code generation at the Kotlin compiler stage. That means it's super, super early, super, super fast. The benchmark we are doing here is that for a project with 1,000 components is still taking less than 2 seconds to generate. Then it's mostly instant. You can rebuild everything from scratch. It will still take 2 seconds to generate. Because then we have just the DSL configuration to generate for you. And the other good thing is that you can debug inside if there is something wrong. Then you can really understand everything in terms of annotation, DSL generation, and take finally the best way you want to write Koin. And it's not just DSL or annotation. You can use both. Use really the thing you want to, that really is close to your need, finally. If you want to look at the project, and it will be soonly available for the first stable version, there is the URL on GitHub, and then you can look at all the sources if you want to dive into Google KSP generation. I get in my last section of this presentation. What's next about Koin? just to give you an overview of how many people are using Koin, in 2020 there were 5 million downloads over a year, in 2021 9 million downloads, and in those months, since last year and in 2022, we are on the trend of 5 million downloads of Koin by month. Then it's really getting it's really getting more and more used, and then it's super great to see more and more people using this and then adopting Koin over and over. It's great, and you can have many old type of application. You can have banking, you can have multimedia, streaming, everything. There's really lots of usage behind it. Then, finally, from the past, we need really to structure all those versions, because we can't just go and ship new features like that. We need to structure, and also the need of structure is that JetBrains is structuring for life cycle of 6 months. Android is structuring every kind of library for a milestone of 6 months. Then we need to adapt our way to work with this life cycle. That means that really we want to structure fixed version, minor version, where finally we want to differentiate for you and really understand if it's just a patch version to fix things that can be broken, minor version with deprecation, minor features, and major version where finally we introduce really hard breakings to really help you understand how you can update and where you can also get the latest feature and how you can update for your code, because when you have a huge code base, you can't upgrade your dependency injection just like that. Then you will understand how we can work and bring new feature for the next coming months. Koin 3.1 is getting in its end of track. As I was saying, the first version of Koin 3.1 has been started last year in Q4, I believe. Then for Q2 this year, we are targeting the new Koin 3.2 and Koin Annotation 1.0. And Koin 3.2 is bringing really new, amazing stuff, like a new DSL that avoid you to write get. We want to target directly your constructor of the classes, and then you won't have to type or update your constructor if you to update your configuration if you update your classes. And this is really a good thing, because in the community when some were talking about Koin, they would say, okay, there's a configuration with get, and then with the new Koin version, you won't have to do that anymore. The other stuff will be the module includes. Will help you to include in a real hierarchy of modules, and will flatten everything for you, and then you can depend freely of whatever you want. Then there won't be any more conflict in terms of module organization. And of course, late for this year, we want to target new feature for Koin and really have open product for Koin for Compose, targeting all the multi-platform Compose technology. If you are still in Koin 2.x, is there in the room people that are still using Koin 2.x? Okay, just a few one, but you need to migrate, because then this is really out of support for the community. And then we have bring so many improvements on the framework that you really need to pass to the new major version. Things to note here is 3.1.3.1.6, the latest stable Koin version, and then you can wait for the 3.0, 3.2.0 soon, with a lot of good things. From the beginning, Koin is driven by the community, and I really thank everyone who contributed in any way to the framework, and then we can make very good idea raise from this, and then we can ship 3 incredible things. But behind that, with the volume of people using that, we need a company to help back up everything in terms of professional services and long-term release, because then there is a company that can't update for every 6 months, that can't embrace new breaking things. Then Codezilla company is helping setting up everything in terms of professional service and support for you. then take some notes, especially for the blog, where finally all the communication will be done on this blog, blog.codilla.io. And then we are hosting everything from Medium, that were the place we were writing stuff. Now we want to host everything on it. And we have goodies. You can ask my friend Michael from Codilla. He can give you stickers and cheat sheet for Koin annotations and Koin 3.2 in preview for you. And that's it. Thank you for your attention. Perhaps we have 2-3 minutes for some question. Yeah.
Hello, thanks. I have one question about annotations. Why we have Koin view model and not just @view model? I don't think it's consistent with other annotations.
No, to answer simply is because there is already in Google an @view model. Then we can't override something here. Then we need another name. Then it's just Koin view model. In Hilt you have Hilt view model, for example. This is because in the view model library there is already something that is called @view model.
Hello, thank you for your presentation. I just had a question about scopes. And do you plan to add annotations with a scope, or is it already here?
Yeah, it's already here. I can't show everything, but you have you can tag a type with just @scope. For example, the activity just say @scope, and then on your component you want to inject, you say @scoped, and then you're done.
Perfect. Thank you.
If you have any question, I'm still in the conference, and then you just find the guy with the Koin logo, and I can answer your question. But I believe it's time to lunch. Thank you.